Our planet is a dynamic and ever-changing place. From the vast expanse of oceans to the towering heights of mountains, the Earth's surface is a tapestry woven with diverse landforms. Understanding these landforms is crucial to comprehending the forces that shape our world. One of the key elements in understanding landforms is relief. Relief refers to the variations in elevation across the Earth's surface. Imagine looking at a flat piece of paper. This paper represents a world without relief, a uniform and featureless plane. Now imagine crumpling that paper into a ball and then flattening it out again. The wrinkles and creases represent the Earth's relief, the mountains, valleys and plains that make our planet so unique. Relief is the difference in height between the highest point and the lowest point in a given area. Relief is not merely a visual aspect of our planet. It plays a critical role in shaping weather patterns, influencing the flow of rivers and determining the distribution of plant and animal life. Understanding relief is fundamental to grasping the interconnectedness of Earth's systems. In the vastness of the cosmos, Earth stands out as a planet teeming with life. Its diverse landscapes, sculpted by the forces of nature, are a testament to the power and beauty of our universe. By studying relief, we gain a deeper understanding and appreciation for the planet we call home. Elevation is a fundamental concept in geography, and it is inextricably linked to relief. Simply put, elevation is the height of a point on the Earth's surface above a reference point, typically sea level. Sea level serves as a convenient and consistent baseline for measuring elevation worldwide. Think of a staircase. Each step represents a different elevation. As you climb the stairs, your elevation increases. Similarly, as you move from a valley to the peak of a mountain, your elevation also increases. Elevation is typically measured in meters or feet. Maps use various techniques to represent elevation and depict the Earth's relief. These techniques provide a visual representation of the three-dimensional surface of the Earth on a two-dimensional map. By understanding these techniques, we can interpret maps more effectively and gain a better understanding of the landscapes they represent. Elevation is a crucial factor in understanding a wide range of geographical phenomena. It influences climate, as higher elevations tend to be colder than lower elevations. Elevation also affects the flow of water, with rivers typically originating in higher elevations and flowing towards lower elevations. Furthermore, elevation plays a role in the distribution of vegetation, as different plant species thrive at different altitudes. In essence, elevation is a fundamental concept that helps us make sense of the Earth's surface and the processes that shape it. By understanding elevation, we can better appreciate the complexity and diversity of our planet. Imagine trying to capture the grandeur of a mountain range on a flat piece of paper. How can you possibly convey the soaring heights, the plunging valleys, and the intricate details of the landscape? This is the challenge of representing relief on maps. Over centuries, cartographers have developed ingenious techniques to depict the Earth's three-dimensional surface on a two-dimensional plane. These techniques provide a visual language for understanding elevation and the shape of the land. Each method has its own strengths and limitations, and the choice of technique depends on the purpose of the map and the level of detail required. Some of the most common methods of relief representation include hatchuring, hill shading, spot heights, layer tinting, and contour lines. Each of these techniques uses different visual cues to convey information about elevation. By understanding these techniques, we can unlock the secrets hidden within maps and gain a deeper appreciation for the landscapes they represent. Maps are more than just tools for navigation, they are windows into the world around us. By mastering the language of relief representation, we can read these windows with greater understanding and explore the Earth's diverse landscapes from the comfort of our homes. Section 4. Hatchura's lines of elevation. Imagine drawing short lines to represent the slopes of a hill. As the slopes become steeper, the lines get closer together, creating a visual impression of increasing elevation. This is the essence of hatchuring, a traditional method of relief representation that uses lines to depict the shape of the land. Hatchuras are short, non-numerical lines drawn in the direction of the steepest slope. The thickness and spacing of the lines indicate the relative steepness of the terrain. Closely spaced, Thicker lines represent steeper slopes, while widely spaced, thinner lines represent gentler slopes. Hatchures create a visually intuitive representation of relief, allowing the viewer to perceive the shape of the land at a glance. One of the advantages of hatchuring is its simplicity. Hatchures can be drawn relatively easily, even without sophisticated surveying equipment. However, hatchuring has its limitations. It does not provide precise elevation measurements, and the subjective nature of line placement can lead to inconsistencies in representation. Despite its limitations, hatchuring remains a valuable technique for depicting relief, particularly in small-scale maps or artistic representations of landscapes. Its ability to convey the general shape of the terrain with minimal clutter makes it a useful tool for cartographers and artists alike. Hatchures are a testament to the ingenuity of early mapmakers, who found elegant ways to represent the complexities of the Earth's surface using simple lines. While more sophisticated methods of relief representation have emerged over time, hatchuring continues to hold its place in the cartographer's toolbox. Section 5. Hill shading, shadows and light. Imagine the sun casting long shadows across a mountain range, highlighting the peaks and plunging the valleys into darkness. Hill shading, also known as relief shading, mimics this natural phenomenon to depict relief on maps. Hill shading uses variations in tone or color to simulate the effects of light and shadow on the terrain. Light-colored areas represent slopes facing the light source, while darker areas represent slopes facing away from the light source. The result is a visually striking representation of relief that creates a sense of depth and dimensionality. The effectiveness of hill shading depends on the angle and direction of the light source. A low sun angle casting long shadows accentuates subtle changes in elevation, while a high sun angle produces a more subdued effect. Cartographers carefully consider the position of the light source to create the desired visual impact. Hill shading is particularly effective at conveying the overall shape and morphology of the terrain. It can highlight subtle variations in elevation that might not be as apparent using other methods of relief representation. However, hill shading does not provide precise elevation measurements. Hill shading is a powerful tool for creating visually appealing and informative maps. By harnessing the interplay of light and shadow, cartographers can bring the Earth's surface to life on paper, allowing us to visualize and appreciate the beauty and complexity of our planet's landscapes. Section 6. Spot heights and layer tinting. Pinpointing elevation. Imagine looking at a map dotted with numbers, each number representing the exact elevation of a specific point on the Earth's surface. These numbers are known as spot heights, providing precise elevation measurements for key locations. Spot heights are typically marked with a dot or a small triangle along with the elevation value. They're particularly useful for identifying the highest points of hills and mountains, as well as other significant elevation points. Spot heights provide valuable information for a variety of applications, from engineering and construction to navigation and recreation. Another method of relief representation that uses numerical values is layer tinting, also known as hypsometric tinting. Layer tinting involves assigning different colors or shades to different elevation bands. For example, lower elevations might be shaded green, while higher elevations are shaded brown or gray. Layer tinting provides a quick and intuitive way to visualize the overall elevation patterns of a region. It is particularly useful for identifying areas of similar elevation and for highlighting changes in elevation over a large area. However, layer tinting does not provide the level of detail and precision offered by spot heights or contour lines. Spot heights and layer tinting are valuable tools for representing elevation on maps. They provide complementary information, with spot heights offering precise measurements for specific points and layer tinting providing a general overview of elevation patterns. By combining these techniques, cartographers can create informative and visually appealing maps that effectively convey the shape of the Earth's surface.